Alright folks, welcome back to another Math Notes video. We're in section 7.1.4, properties of logarithms. Now I've talked about some of these properties already, so we're just kind of summarizing those here. Let's go through them right now. Okay, so the very first property we learned was back in chapter 5, the definition of a log, where we knew that log base b of y equals x means the same thing as b to the x equals y, or y equals b to the x, for any y that's not 0. Next thing we sort of discovered was the product property. So we said that if you have log base b of m times n, that's log base b of m plus log base b of n. So for example, if this was, say, 4 times 5, this would be log b of 4 plus log b of 5. And of course 4 times 5 most of the time would be written as 20. Okay. Quotient property says log base b of m divided by n is equal to log base b of m minus log base b of n. So to use our another example, if we had, say, log of 4/5, I'm writing with the mouse, so bear with me here, that's equal to the log of 4 minus the log of 5. You'll notice that this is very similar to exponent rules because logs are just the inverse functions for exponents. Power property. This says log base b of m raised to the n power is the same thing as n times log base b of m. So if we had, say, 2 to the third power, then that would be the same thing as 3 times log base b to the second power. Okay, so we can bring that exponent out front. And that makes sense if we go back to our product property, because this would be 2 times 2 times 2, which would be log 2 plus log 2 plus log 2, or 3 times log 2, right? So this is a kind of an expansion on the product property. Let's look at some quick examples here. You can use this to simplify expressions if you know some specific logs. And back when people used log tables, this was a little more important than it is now with our calculators. But it's still pretty handy to do a nice little math puzzles here for us to solve. So if we think of log base 3 of 36, we can do a little factor tree and realize that 36 is the same thing as 6 times 6, or 2 times 3 times 2 times 3, or 3 squared times 4. And the reason they've chosen 3 squared times 4 is because we know the value of log base 3 of 3 would be 1. So if we have that twice, that's 2. And then log base 3 of 4 is given right here, 1.2619. So we say 2 plus 1.2619, we get 3.2619. Okay. Second example, log base 3 of 7. Well, they've only given us log base 3 of 28 and log base 3 of 4. So we want to figure out how we can get a 7 out of a 28 and a 4. Well, if we divide 28 by 4, that'll give us 7. And then our quotient rule up there tells us that when m is divided by m, you can subtract the denominator from the numerator. So log 28 minus log 4 gives us 3.0331 right here, minus this number to get that number, okay? And finally, log base 3 of 256. If we factor 256, sometimes helpful to do a little factor tree with those. You do a factor of 256, that's going to be 16 times 16, which would be, each of those would be 4 times 4. So 4 to the 4th power gives you 256. So this is the same thing as log base 3 of 4 to the 4th, or 4 times log base 3 of 4, which comes out to 5.6 0.0476. Okay. All right, so after you sort of looked at those examples a little bit and understand how they work, I want you to go over here and try some on your own. Use log properties to evaluate each expression. That should say without a calculator. Be sure to show your work. Let's fix that real fast. Without a calculator, be sure to show your work. So write it out in the steps like they have down here in the examples. All right, guys, have a good day, and we'll look these over in class. Thanks.